In this video, I'm going over a few things that apply to correlation in general, regardless of what kind of correlation you're doing. Correlation is used to find a relationship between two variables. All it's telling us is how strong is this linear relationship. These numbers down here, these are R, the correlation coefficient. Here you can see some examples of a perfect positive correlation and perfect negative correlation, and things in between. Correlation is only useful for linear relationships, at least the correlations that we're going to be talking about in this class. Something like age versus strength is, over the entire lifespan, curvilinear. So you would not want to use correlation for that relationship. However, within a shorter time span, say from ages 6 to 10 or 6 to 12 or 65 to 80, it might be linear, and you could use it for that subset of the relationship. Outliers are a problem for correlation. So just one outlier here can dramatically reduce the strength of the correlation. When you're performing correlation, if you get an outlier, you should keep it in. The only reason to eliminate an outlier from your data is if there's some causal explanation that really is different for that particular data point. If you can't think of something or identify something that explains why this data point really is an outlier, you should keep it in. You also need to collect a wide enough range of data to cover the things you're interested in. So if you're interested in the strength of 12-year-olds, you need to capture at least 12-year-olds in your data. So measuring strength in children ages 6 to 10, you can use that relationship for kids between the ages of 6 and 10. You wouldn't want to stretch it to kids who are 12 years old. And similarly, if you think there might be a relationship, you want to make sure you capture that part of the population. Otherwise, you may miss it. We covered this a little bit in psychometrics. You want to have at least 30 data points in your data set. That's not a rule. That is a rule of thumb. At 30 data points, you're crossing a threshold where your confidence intervals are going to be reasonably tight for middling values of the correlation coefficient. So I'm happy to go into more detail about why 30 is a good cutoff, but you can just take it as a rule of thumb. 30 is an appropriate cutoff for how many data points you should have at the minimum.